So what we're doing here is just a little short video on graphing piecewise functions. Because piecewise functions, or we define it as a piecewise function because of the fact that it has different pieces that make up the overall function. Now we do have certain conditions, don't want to carry on highlighter, for each of these piecewise functions. So let's do that green and that purple. Green, purple. And depending on the x value is going to depend on which of these three pieces of the function we'll use. So for the first one, whenever our x values are less than 1, we use it. When our function is equal to 1, we'll use it. And whenever the function is greater than 1, we'll use this here. Now, since it's a single value, well, it ends up being we're just talking about flat lines. So for x less than 1, so all the values on the graph less than 1 going this direction, we would be using the top function. So the top function is just 3. So less than 1, so we'd come to 3, circle it, and it'd be all the points to the left. So it'd just be this here. The middle one, x is equal to 1. Whenever x is equal to 1, we have a value of -2. And since it's equal to, we put a solid dot. I did an open dot on the first one, mainly because it's less than, it's not equal to it, so we have open. And the last one, if x is greater than 1, we have -1. So a -1, because it's just greater than, we have an open circle, greater than, we draw a line to the left, or right, sorry, not left, to the right, and that's it. Yeah, so with 3 numbers, this is all we have. Now, I decided to go on and do another one. Found this one here. And I like this one a little better because we're actually looking at graphs, not flat lines and dot. Now, the top one is for all values of x, or if x is less than 1. The bottom one is if x is greater than or equal to 1. So all we've got to do is graph these two here. Now the bottom one out of the two is a little bit easier to graph because this is an equation of a line. And to graph the equation of a line, we need 2 points. So we have 9x minus 7, or we can say y is equal to 9x minus 7. Now the condition here is that x is greater than or equal to 1. So again, we need 2 points. X, y. 2 points to graph a line. One of them I'm going to use is 1, because it's equal to, even if it wasn't equal to it, that gives us a starting point, because that there is the smallest value of x we can have. And we can plug it in. Color. Y is equal to 9 times 1 minus 7. Well, 9 times 1 is 9. 9 minus 7 is 2. So we get the point 1, 2. I'm going to plot that on the graph. Now, since it is equal to 1, we would have a solid dot there. Now we need another point. Doesn't matter what it is. As long as the other x value is greater than 1. I'm going to say 4. We can do the same thing as what we just did. Y is equal to 9 times 4 minus 7. Well, our 9 times 4 is 36. 36 minus 7 is, I don't even know why I just drew a 3, because that is 29. Okay, well, that is another point, and that would work, but that is somewhere off here. So I'm going to pick a different point, something that is located on the graph. Well, in that case, now we can go on and pick 2. I didn't pick 2 originally because I thought the points would be too close together, but apparently I was wrong. Because if we plug in 2, 9 times 2 is 18, 18 minus 7 is 11. So our other point is 2, 11, which is this point here. And what I mean by I was wrong is I thought 4 would be contained in the graph. I didn't even look at the graph or expect what the numbers would be, but we have this here. Now, we're not going to specifically have a line. We're going to have a ray because we do have one endpoint that is a closed endpoint at the point 1, 2. And it continues on through the point 2, 11, and it goes all the way up to our 429. And then that is half of our graph. Now the other half of the graph is this here, 1 plus x squared if x is less than 1. Now again, we're going to need some points to graph this here. Now one of the ways that we can do this, and it's pretty simple, is to just graph x squared plus 1 and see what that graph is. And for these here, when we graph a quadratic function, we need 5 points. 5 points on a graph. In the center point, we always look for is the vertex. Vertex is our smallest point. Now there's 2 ways we can get to that, and one of them is using standard form. Y is equal to a times x minus h squared plus k. Or if we have it in standard form, ax squared plus bx plus c. Now technically this is in vertex form, our top form, and that it just doesn't look like it because what we actually have is this here, and our h value is actually 0 because we have x minus 0 squared plus 1, which tells us that the vertex for this is 0, 1 is our vertex. So that's nice to know. Now if it had been in standard form, I'll add this here as a side note, ax squared plus bx plus c. To find the vertex, we would use the point negative b over 2a comma f of negative b over 2a. So we start off with plugging in the values of a and b into this here. And once we get this value, we plug it into the function to find its corresponding y value. So we found our vertex, which is 0, 1. And we need 3 or 4 other points. And conventionally, we'd pick 2 points to the left, 2 points to the right. Now, the 2 points to the right are going to mean nothing in the overall problem because, again, for this here, x is less than 1. So 1 and 2 are actually out. But, especially for this program here and getting the equation of the graph, we'll need them. And we can start off by just plugging these in. So we can start off with negative 1. So we'd have negative 1 squared plus 1. Well, negative 1 squared is, well, 1, and 1 plus 1 is 2. So we have negative 1, 2. Incidentally, if we do the same thing with positive 1 squared is 1, 1 plus 1 is 2. And the reason we get this mirroring shape is part of the properties of a quadratic. And we have something called the axis of symmetry. And everything across this line, this axis of symmetry, will be mirrored. And it actually works out that the axis of symmetry always goes through the vertex. So the values of y on the left and right of this parabola should be and will be the same. So if we do the same thing for negative 2, negative 2 squared plus 1, well, negative 2 squared is 4, 4 plus 1 is 5. And if we check it with the last one, 2 squared, 2 squared is 4, 4 plus 1 is 5. So we can graph these points here for our quadratic. So our vertex 0, 1, 1, 2, 2, 5. And then we have negative 1, 2, negative 2, 5. And this here would be our quadratic. Now, with this restriction here, we actually don't have anything greater than 1. And at this point here, we actually have an open circle, so it's not included, and we get this here. Now, if you're using the program here, you can use this here to make the point, and then cut the side off that you don't need. And this would actually be continuous. But that's all we have for this here.